Okay, so in this second part, the thing we're going to do is we're going to add some UVs to the landscape. Now, the thing what we see over here is we have already our landscape together with our road going over the landscape, but without any UVs, it's actually a little bit useless. So that's the first thing that we're going to do. Now, how are we going to get UVs? Well, there's one thing which is very practical, is we can get UVs very easily if we take them from a NURBS surface. A NURBS surface is always like a quad shape, in fact, which is defined by U and V parameters. Now we can find them over here. We have like this line that we swept into this road-like shape. So what we can do over here is we can change this into a NURB surface. Now there are several ways how we can do this. We can convert this shape, or we can just change our line as an input over here. Right now our line is as primitive type set to polygon, so we'll set that to NURBS. So the moment when you do that, you'll see that this object is a NURBS object, one NURBS surface. Now you see that this node is complaining. It says the curve should not be built with, could not be built with the specific parameters. That is because it's asking for a NURBS, and as you can see, it needs at least 4 control points, and we only have 2, so we have to set it to 4, and then you'll see it stops complaining. Okay, so let's create a few things that we can use right now. One of those things is creating the UVs. Now you can find them when pressing tab. You'll find them over here in material. Now there are like several kinds of UV creation tools, but the one that we're going to use right now is the UV texture. It's a node that allows you to create multiple UV mappings at one time. So as you can see right now we set to orthographic in the y-axis and using a natural location. Natural location means most of the time that it's going to use points by default. So you have points and you have vertices. So let's have a look at our UVs. And the way how you can get to this view is by pressing spacebar 5. So here you see the UV view, and here we see everything laid out nicely. So if you're going to create a material you can find over here, the material palette, and the one that we're going to create is a UV map. So I'm going to drag it off over here and dropping it right here in the shop network. Now you might wonder where that material just went to, and we took it over here, we dropped it into the shop network. Well, the shop network is also part of one of those paradigms we're talking about. So we have over here object, and we have right here shop. So here you see where it's being dropped. Shop shader operators. Okay, so the thing we need to do right now is, besides having the UVs, we need to add a material as well, and also this happens with a node. So you just have a material node, and this is quite straightforward. So the things what you have is you can increase the numbers of materials, as you can see. You can add a material to a certain group, so if you have like several groups you can add material to that. And right here you can pick the material, and over here there is override using local variables, etc. This is something I will have to talk about later, because this goes a little bit too deep into details. So right here we're gonna click on this icon, and this allows you to get to that node immediately, to that operator. So it's going to show in this view only the shop networks and which material that you can select then. So we are going to apply that, and you should see this in your viewport. Now it might be that you're seeing nothing right over here, and one of the reasons could be that in your preferences in the 3D viewports you have your scene rendered set up to Houdini 11. So if you accept that, you see you won't see anything. It just needs one update. it still seems to work. Okay, so that's something you could do if you would have any problems with that. So I'm going back over here. We need 3.2 and accept the newest or the latest version of the shader. Alright, now this allows you to have like different kinds of UV mappings. So we have like x-axis, we have like z-axis. Well, it's all kind of trivial, I guess. Now, if, like I said, we have natural location. That was something I was talking about. By pressing spacebar 5, you see over here what type it is, and you see that it is saying point. So it's using now the points to define the UVs. So if you change that to vertex texture, you see that you can control over here what you need to use. Now make it a good habit to always use vertex textures. It actually doesn't have a lot of use, or it's not like really practical to use points as UVs. And this is also something I will explain to you in a later session, why it's so important to use vertex textures. But for now, just keep it as it is. Okay, so let's select some other projection types. With polar. Polar is something which you could compare to a spherical type of mapping with cylindrical type of mapping. You have rows and columns. So it's going to use all the rows and columns you see over here. But when you use rows and columns, you will see that there's most certainly a lot of stretching happening. So you see some of the parts are very long, some of the parts are very short. You have also uniform spline, you have average spline. And as you can see, these are not giving exactly the results that we want. Also over here there's a lot of stretching. In each segment the full texture is encapsulated, so you have like parts which are bigger, you have parts which are smaller. Now there are a few ways how we can solve this. One is to change over here in the sweep the skinning type. Now it's set to skin with auto closure. If you set it over here to skin with preserve shape and auto closure, it's going to have like a totally different kind of definition in the UVs. Now let me switch back to the UV view, and you can see over here the result. So right now, skin with preserve shape and auto closure, it's going to maintain all the differences in distance for each one of the segments. You see like this unequal spread of all these little parts. This is exactly what you need in order to avoid stretching. Now if you do skin with auto closure, you see that on each unit there is at each time a segment. So this is not going to work. This is going to make sure that there is that stretching is going to happen. So make sure to set it to skin unclosed with preserve shape. So that's one method. Now another method might be the following, is that you keep it over here with auto closure, and there's something in which you can change the whole style of mapping of the UVs. So what you can do over here is, if you go to primitive, no, sorry, not primitive, to NURBS, there's this tool called basis, and in this basis tool you can start to redefine how that NURBS shape is going to be represented. So let me select it over here, and here we see the U basis or the V basis, and here we can set how we want to use it. So in order to see the V basis, and here you can see how things are being adjusted. Approximate arc length, approximate arc length. So if you're going to change this right now, and I'll guess I'll need to make this much smaller then we're kind of fixing also the stretchiness. It's not perfect, as you can see, but it is way better than it was before. So there is still some stretching happening, but it's way less apparent as before when we were deactivating this. So basis might be a solution to that as well if you don't have the opportunity to change it right here. But as you can see, this will still give you a much better result. Okay, now the other thing that we want to do is we want to make sure that this texture is always going to fit nicely in between those rules we set over here. So if we're going to change this value, see with a value of 23, we get something like this. Now, this is something you might try to solve. So over here we have the length of this line and we have the length of this curve. So what should you do in order to make sure that they are proportional to each other? So try to solve that over here using some measurements or some nodes or some expressions, and try to solve this. If not, I'm gonna show you the solution to that. The node that you can use in order to try to solve that is the merge node. The node you can use in order to try and solve that is the measure node. Okay, so let me use now the measure node. We have over here this line, measure, and this measure node does a lot of things. We have, like over here, perimeter, and it allows you to measure all kinds of things. So the perimeter is like the whole length of a curve, or if you have like one polygon, the whole circumference of or if you have a polygon, it's like the whole perimeter of that polygon as being set over here. Now you can do other things as well. You have like area, which is going to measure the area size of each primitive. Curvature, which is going to add to the points the level of curvature there is on a surface. So you can't use it to measure the curvature of a line, but you can use it to measure the curvature on a surface. So this is also very useful to have. You can find the parts which are sharper and the other parts which are smoother. And this is volume, and with this you can measure the volume of a closed object. Okay, so we're going to leave it at perimeter. We have the value that we need over here. So what we need to do is we need to just divide actually the length of this curve by the length of this line, and this is going to make sure that it's always going to fit nicely and that's going to be in tune with the width of this line. So for that we're going to use the prim expression. Prim expression is like point expression. You can get an attribute from a primitive, and as you can see with this measure node we have created a new attribute called perimeter, which is stored in the primitives. So with this expression prim, we can refer to that node measure 1, and then we're going to say which primitive. Since we have only one primitive, it's not an issue. So we're going to select primitive 0, then the name of the attribute that we're going to take, perimeter, and then the last which index. And since there's only one value, we take just index 0. And this one we're going to divide by the channel of the line 1. And from that line 1, we're going to take the distance that you see over here. So this simple solution gives you immediately a perfectly normalized UV. So now you can start changing the distance over here, and as you can see it will automatically update and make it really nice and fitting as it should be. So that's the whole principle. There's not much to it. I'm gonna set this back to 3. Alright. So now what are we going to do? Well, we have created like these UVs, and I've stored this into something separate, so I'm going to move it back over here in between this null. Remember, what we did over here is this sweep, and this is the place where we rate that sweep onto this surface. Now what's special over here? We have in this array, by the way, I'm going to change something over here because the array direction is not being set. It's being set right now. If you have like a Houdini version which is older than this one, you can use an external normal. So you can see over here it's using the incoming normal. Now I've just overridden that. Right. So what am I going to do right now? I've created UVs. We've seen that these UVs are also vertex UVs. Also pretty important to know. So in here, the thing I'm going to do is I'm going to import attributes from hits. And so what this allows you to do is that each time when a vertex is hitting this surface, the surface of this ribbon that we've created, it will allow you to get the attributes on that specific point or on that specific location of the hit. So with UVs we can just get all these UV values over here. So if we type in UV, and that's the attribute that has been created. If you middle mouse button click, you see it over here, one vertex attribute UV. Then we have transferred all these UV attribute values to this surface. So if you're going to connect a material over here, we see immediately that we have our UVs on a totally different kind of shape. So if we check the UVs over here, you see this whole geometry being used over here. Okay, so the next thing what we need to do is to make sure that we can have it working right over here, because right now if I'm going to add a material, we're not going to see anything. Now why is that? The reason is because we have our UVs in the second input port of the point, and we need to have our UVs over here into this smooth input port, the first input port. Now there are several ways what you can do. First one, perhaps the easiest, is you can just reverse and change all the values over here so that you're taking the info from the right input port. So everything which is 2 becomes like the first input port, and everything which was the first input port becomes the second input port. So like this we have our UVs on the landscape. That's one way of doing it. Now another way of doing this, let me go back. Okay, we have the original situation. We can in fact transfer or copy attributes. You have over here attribute copy. So let's try this. This is the first input object, and this is the second input object. It's complaining. So what kind of UV are we what kind of attribute are we transferring? We're transferring the UV attribute. And so if you look over here now, it's also transferred that way. So we have, since we have exactly the same numbering and exactly the same point order, we can just copy these attributes right over to this part. Now suppose we have something more difficult, another situation. We can do the following. Imagine that we are going to optimize over here our surface. So let me see, I'm going to widen the road a little bit. I'm going to make this width of 2, so it's a little bit wider. I'm going to make sure that the mountain is not that high anymore, because it's like really high. let's set it to 5, which is then a little bit more realistic. Okay, something like this. And we want to optimize the geometry we have over here. Now you can use right over here in the utility, I guess it's in utility, or no, it's in polygons, the polyreduce node. Let's see over here. If you use polyreduction, it's going to 3 divide it by default. Now if you're going to start removing a set of it, you're going to see that especially this road is going to be visible. And so it's doing some nice optimizations over here. I can reduce it even a little bit more. Something like this. Now if you're going to check this material that we have, of course we have like a lot of skewing, etc. going on. And now this is something we really need to avoid. So what can we do? There are multiple things. First of all, the thing that we can do is we can create like a second ray. So in this case we're not going to import the attributes, and we're going to do like a second ray. So we have over here ray, and in this ray I'm going to set again the value, and I'm going to transform over here this path just a little bit higher, because it's already colliding with it, so it's already following exactly this shape. So I'm going to put this a little bit higher, and gonna make sure that this object is being rayed again to the surface. Now I'm not going to transform the points anymore, but what I'm going to do is I'm going to again import the attributes using the UVs and doing it then over here. So that's one method that you could use as well. So that's just making sure that the transferring happens a little bit later. There's also another method that you could use instead of using ray. Let's put this to the side for a while. We're not going to change the height over here, but what I can do is I can use an attribute transfer. Now we did over here already an attribute copy, which I can remove for now. An attribute copy, and an attribute copy works only if the points or the number of vertices, or sorry, the number of, this only works if the number of points are exactly the same and if you have like the same layout, the same topology. So what we're going to do is we're going to use a system in which you can share that data but without having the same topology, and that's something with an attribute transfer. So the copy is easy. The copy is going to transfer the data from one point to another. The transfer is different, since it's going to make like a weighted difference or a weighted value between all those things. So let's go over here, and the one that we're going to use is UV. And let's see what's going on. We have to transform here first, so I need to do it without the transform, of course, so it's closer to the surface. Attribute transfer, and we still see nothing. What's going on? Do we have UVs over here? No. We do have UVs over here, and that should work in fact. Like multiple sample counts. This is strange. This is supposed to be working. So we are literally copying the UVs. Now it might be that it doesn't work for vertices. Now let's change this, just for the heck of it, into a point texture. And let's see over here. So I'm going to switch this off. And using points it seems to work. And here we can start playing around with the conditions. Now there are a few things that you need to take in account. Over here we see the distance threshold, so the range that you can use. And right here you have the sample count, so the more samples you take, the more it's going to blend in between those. And kernel radius is the radius it's going to use in order to blend those values. So you can change this also, make this a little bit wider. Now it seems to work more or less, but it doesn't give me exactly the results I had in mind. So a few things you might be able to pull off is, for example, you could convert, but I think with conversion you're going to lose the UV data. No, you don't. So what we can do is start adding like a lot of span detail, and that would get it a little bit closer to what we need. Let's see if I'm going to reduce the radius over here. It's not really working out that well. Even with a higher sample count, it smooths out a little bit, but on this type of landscape it's not that beautiful in particular. So let's have a look over here if we render this result, because it might be because of the polygons. But no, still in the rendering we see that we have some distortions over here. So this is not exactly what we need. And we see over here these distortions, it's not going to work perfectly. And these are too many points. Well, you can tweak it just a little bit to get it almost perfect. It works to a certain degree. So that's the blending width, how far you will blend the UVs from one surface to another. But it's also similar to distance threshold. So distance threshold is how far or how much it's going to look in order to take some points into account. The kernel radius is actually the radius, the blob radius. It's using some kind of a blob shape, and you can use all kinds of different blob models. I think you have the uniform model, exponential bump. Well, in order to show this, it's better to show it on a line actually. So if we have a line, now in order to explain this properly, I think I'm going to use a small line, which I'm going to subdivide, and in which I'm going to use a few points, which we can then use to do an attribute transfer. Let me do that first. So I'm going to create a line over here. And making sure that I'm using over here my shortcut, giving it a bigger distance. And this one I'm going to resample quite a lot, so that we have a lot of detail that we can use. And this version I'm going to resample just a little bit. In fact, I'm only going to sample it with a maximum number of segments, something like this. And this one point I'm going to give an attribute. Now let's put it this way. I'm going to transfer this one upward, so that we can see it has like a certain distance to this curve. And with an attribute create, I'm going to give this first point a special attribute. Let's say that the attribute is gonna be a normal. Or capital letter N. Well, let's do it this way, because then we can see exactly what's going on. We're going to use a vector for that, and the normal direction is going to be just upwards. Great, so that's what we're seeing, and the only point that I'm going to use is this one. I'm going to set it to the first point so that we can see the difference between those points. Let me lower this to half, like that. And now we're going to do an attribute transfer. Up. Attribute transfer. So in this attribute transfer, we're going to transfer some attributes on this line from this line. And as you can see, it's doing automatically for all of them. You can set the name here by default. And so what are we seeing right now? Here we see the conditions. We have like a maximum sample count. So it's gonna take, in this case, just the closest one which is near. If we take now 2 sample points, we see you have like this gradual blend. So in this case it's going to have like either this point or either that point or either that point. Now in this case we're gonna have like a smaller point. Now we have the kernel radius. The kernel radius, like I said, is like the blend function. So if we gonna make this smaller, you'll see over here the effect. Now I'm gonna change something. I pressed D, shortcut D, so I can change over here some effects on the viewport. And what I'm gonna change right here is the display length of my normals. Where is it? Wireframe tessellation particles attributes, here the scale normal. Set it to 1. And I'm gonna look at it this way. So now it's much easier to see what's going on right over here. Now you can have like this soft blend function, but you have also like this distance threshold, and this is like the range which is going to use in order to check which is belonging to which. And so as you can see over here, when we reduce this, we're limiting this kind of effect. So when I make it smaller, it's not grabbing anything of the attributes, so it starts to miss those things. You can see them as being like these big circles around this line. So on each line we have like this point, and they are now having like this big circle range with a distance of 1.18 radius. So that's why we have like this whole thing being selected. So the bigger we make it, the more we see of this. And so if you increase the sample point, if we would have like more points, we're going to see like, of course, more blending occurring. So that's the whole issue. And here you see like when you start skipping through each one of these models, you see how the blending works and gives you like different kind of effects. Okay, so this is how you transfer attributes from one to another. And this is what we did over here. So we tried to tweak it in such a way that we had it more or less in a stable manner. But as you can see, is the first option I did over here is actually much better. So this is about it, about attribute transfer. Now the third section, I'm going to show you how you can use attributes in order to place or in order to control, let's say, the scatter node.